Okay, now that we have the pins all labeled for where we need to wire our circuit, if we're going to have to do this on TinkerCad, we'll go ahead and log into TinkerCad and do this. Log in, create a new circuit, go to the circuit section. And again, what we're replicating here with this circuit is what we would do manually with a physical breadboard. So back here at TinkerCAD, let's just go ahead and go for all components, and let's give this a good name. This is A, C naught. Well, what do we do? A naught C or A C naught. Or A B naught C. So that's the circuit that we're doing here for lesson 2.1.3. And under, let's search for all, and let's bring in, we search for breadboard. Let's bring in the full-size breadboard. And then let's also bring in a small breadboard. So this is kind of going to replicate a little bit what we do with our breadboard companions. And then we need some power. So let's bring in some batteries. With a 1-volt battery, if we bring that in, we actually have to have the ability to bring in 3. And then let's rotate that around. And of course, we want to keep our color scheme here. Red for power and black for ground. Okay, and then since we have 2 of these going on, let's go ahead and just wire just so we can get power and ground anywhere we want to. Go ahead and wire the second breadboard together as well. So we'll go ahead and wire the ground, and we'll also wire the power. Now, I don't know how we'll use this. It depends on how we put our components in, but this will get everything wired for us so that when I get to it, I don't have to think about it. Okay, what else do we need? Well, we need some switches. And the easiest way to do this is to use the dip switch here. And we're going to wire this side of the switch to power. So this is kind of like mimicking our breadboard companion a little bit in that I have my power supply as one board, and the breadboard companion already has the switches on it. And the other breadboard is where I'll have my chips. So what do I need? I'm going to need some digital components. Now the TTL chips we're using, let's see, let's search 04. So there's a 7404. Now this is an HC04, which is a slightly different package than our TTL chips, but this is the same, has the same functions and same pinouts as a 74 LS04. So let's go ahead and bring that circuit on. And then we need an 08. So we'll go ahead and bring that out. And then we also need a 32. So that's our inverter, our AND, and our OR gates. Now, on here, each pin, we have the little dot that shows us pin 1, and each pin 14 needs power, and pin 7 needs ground. So let's go ahead and wire all those to power and ground. And this is the same exact thing you would do if we were wiring on a physical breadboard. And again, I'm going to keep my color scheme going here. Oh, I got that one in the wrong place. Okay, so now what we need to do is basically we need to wire from our circuit diagram. So we have labeled what do we have here? We have ABC. So whatever switch we're going to use to represent A, that needs to go to pin 1 of the inverter chip, pin 1 of the AND gate, and pin 10 of the AND chip. So pin 1, switch 1 needs to go to pin 1, and let's, keeping with the color scheme that I did on Multisim, let's keep that blue. And then that also goes to pin 1 on the AND gate. And let's see, which other one was that? It went to pin 1 on the inverter. It went to pin 1 on the AND. And pin 10 on the AND. So you don't typically want to wire across things. So I'm going to just kind of come over here. Let's see, that's 8, 9, 10. Okay, now if you have that gate physically in front of you, when you wire things, it's a good idea to check things off. So you would want to have the, if possible, print the circuit. I know I've got pin 1 wired to 1. I've got switch 1 wired to 1, 4, and 10. So I've got all those done. Okay, so now I'm just basically going to keep going with my circuit. Switch 2 is going to go to pin 3. And that's the only place it goes. So switch 2 is going to go to pin 3. And we'll go ahead and just keep that green. And switch 3 is going to go to pin 5, and pin 13. So we'll go ahead and wire 3 to pin 5, to pin 5, and then also to pin 13. So I can kind of connect any one of those and kind of weave it through. And let's make those purple. Okay, so now I have all of my switches wired. I don't have the inverters wired. So let's see, what else do I need here? Pin 2 from the inverter wires to pin 4. So pin 2 from the inverter is going to go down here to pin 4. 1, 2, 3, 4. Okay, and let's use turquoise. Pin 4 wires to pin 9. So that's output, pin 4. It's going to come down here and wire to pin 9. So I'm kind of weaving this around so we can still see where things are going. And I don't like that that wire disappeared, so let's redraw that. What was that? That's pin 4 of the inverter, goes to pin 9 of the AND gate. And that's why I left a little bit of space, as you can see, kind of between my chips. Okay, so I got pin 4 of the inverter to pin, that's 8, 9. Yep. And then let's see, this inverter, pin 6 wires to pin 2. Is that right? Pin 6 to pin 2. That's a short wire. Pin 6 to pin 2. Let's make that one pink. So now 1 and 2 should already be wired. 4 and 5 should already be wired. 9 and 10 are already wired. I think the only thing left on the AND gate is where the outputs go. 8 goes to 12. So pin 8 is going to go back here to 12. Let's make that yellow. So now on my AND gate, on my AND chip, pin 3 wires to pin 1 on the OR. So pin 3 wires to pin 1. And then pin 6 wires to pin 2. Pin 6 wires to 2. The output of that is pin 3, which wires to 4. So then 3 goes to 4. And then 11 from the AND gate goes to 5. So there's 11. And I'm just kind of snaking that around. That goes to 5. And then that completes the circuit other than what I'm going to display that with. So pin 6 needs to go to a resistor and an LED. So let's go ahead and bring in an LED. And I'm going to put the LED back on the other board because that's kind of mimicking what actually happens when we do this on our when we wire this physically on our breadboard companion. You don't need a resistor and LED. It's built into your breadboard companion as your power supply. So let's see, resistor. And we need that resistor. The negative side is the flat side, or shorter side needs to go to ground. And we should use about a 200 ohm resistor. And then pin 6 needs to wire to the positive side of that. And that completes my circuit. Okay. So at this point, if I start my simulation, now I want to be able to go through my truth table. So now I want to check my truth table. And when I'll go ahead and start my simulation. And when all of my switches are off, I should be off. And then my third A, B, C, when C is on. So I'll go ahead and change that one. It should be on, and it is. And then A naught, B, C naught. So I'll turn that off, turn B on, and it should stay off, and it does. A naught, B, C should go on, and it does. And then A, B naught, C should be on, and it is. And A, B naught, C should be on. So flip switch 3, it stays on. And then A, B, C naught should stay on. And finally, A, B, C should go off. If your circuit doesn't match, perhaps your original multi-sim diagram was incorrect, or perhaps you have something wired incorrectly. But that is the sum of products circuit breadboarded on TinkerCad.